Okay, let's take a look at one. First of all, what do you notice? The difference? Possibly of two squares, right? I mean, this is even degree, so we know it has a square root. This is even, so we know it has a square root. But the 96 and the 6, not so much, right? Those are not perfect squares. But before we attempt, like I said on the previous problem, before we attempt to factor, we should find a common factor that we can pull out. Is 6 a factor of 96? Yes. So I know that I can pull out the 6, and I've also got the x squared from this that I can factor out as well. When I factor 6x squared away from here, I'm left with x squared. When I take the 6 away from 96, taken away meaning division, that's what factoring is, we're dividing that by 6. We have negative 16, and the x squared was removed. Now it's a little bit easier to see, right? We have the difference of squares, which factors into conjugates. Now what do we do with this 6x squared? We don't technically have to do anything. That's one of these factors, right? So the zeros that I get from here are 6x squared equals 0, divide by 6, x squared equals 0. Now this is where it gets a little strange, okay? I'll come back to this in a second because you're thinking, oh, take the square root of 0 is 0. You wouldn't be wrong, but more to follow. X from here we should get x equals 4. From this factor, we get, sorry, I'm all over the place. I gotta slow down. From this linear factor, we get x equals negative 4. So we have what amounts to be 3 zeros, if you will. But I told you, I've mentioned it just briefly, this fundamental theorem of algebra, which states if you have a degree of 4, you should have 4 linear factors, and you should have 4 zeros from those linear factors, which I only have 3. Okay, so let's jump over to the calculator real quick and take a closer look at this. Okay, starting from scratch here. We had 6x to the 4th, 6x to the 4th, minus 96x squared. Was that right? We need to zoom out. There we go. Okay. I was like, where's the negative 4 and the 4? That would have been awkward, right? So you see from this, you can see the 0 here at negative 4 that we found. You can see the 0 over here that's at 4. Now what you see here is you can see the graph come up and then go back down. So what's happened, we have an intersection here, but what's happened is the graph hasn't crossed through that value to go like above or below like it does over in these two. It's essentially bounced off the axis. Okay, so if you can think of it, it's almost like double tapping and then going back. So that's counting that 0 twice. So if you look as we move from left to right, here's a 0, it bends back up, it hits it, bounces off, comes back down, and then back up. So that accounts for the 4 zeros. What we get is this phenomenon of a multiple 0. Okay, the multiplicity of zeros. So if you go back to this, and I know this doesn't make the most sense in the world, but 6x squared is the same as 6 times x minus 0 squared. So since we know 0, the value 0, is one of these zeros, I can write that binomial, and it's x minus 0 as a binomial squared. This is equivalent to this. Do the math. X minus 0 is x. X squared is x squared times 6 is 6x squared. So it doesn't make sense. It's not natural to think of it like this. But this is the same as that. So essentially we do get 1, 2, 3, 4 zeros from this idea. Okay? Don't get me wrong, the factored form that's most acceptable is still here. Okay? But if you're looking at a graph and you're like, well, it doesn't cross the x-axis. No, but it does intersect the x-axis. So there is an intersection, so there is a 0. There is a 0 here. But when you see that bounce, count it twice. It's very strange stuff. Okay? You'll see more of it when you get to pre-calc. Pre-calc, 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 pre-calc.